AP Cal. We're still currently in section 3.2, and this is the second learning target on mean value theorem. Notice the abbreviation is MVT, mean value theorem. The theorem says if f is continuous on a closed interval from a to b, and also differentiable on the open interval from a to b, then there exists a number c in the open interval such that the derivative of f evaluated at c is equal to f of b minus f of a divided by b minus a. Notice that the part here on the right side of the equal sign is the same as just the slope formula. So thinking about terms of like the open interval a to b, when you substitute f of b in, that's the y value. F of a is the y value at a. Y minus y divided by x minus x. So this part is the algebra slope. This part is the calculus slope. Okay, so calculus slope. And this part is the algebra slope. A point exists at which, so the C is the point exists at which the instantaneous rate of change, and recall from the past that that word instantaneous rate of change means derivative, and it is equal to the average rate of change, which is the slope of the tangent line equal to the slope of the secant line. So instantaneous rate of change is calculus slope, average rate of change is algebra slope, and what you're going to do is check out both and make sure that they're equivalent. If they are equal, then the MVT theorem exists. So here are your steps for the MVT. Step 1, you're going to find the average rate of change. So that's your algebra slope. And obviously you need to know the two ordered pairs on the picture. 2 x values, 2 y values. Step 2, you're going to find the instantaneous rate of change, which obviously is the derivative. Step 3, you're going to set the average rate of change equal to the derivative. And you're going to, when you do that, solve for x. And whatever value you get for x, you're then going to check to see if that value is in the interval. If it is, that x value is going to be your c, and then you go from there. So, quick example to make sure you understand like the wording for MVT. Let's say you had this graph in green, and I'm going to call that graph f of x. And notice that this point in red here is at 2, 2. And so we're going to call 2 is the A in the closed interval. And then this location is 3, 4, 5, 6, 6. 1, 2, 3, 4, 6, 4. So the x value here is 6. And we're going to call that the B. The first step in MVT again is to find the average rate of change. In order to do that, you need to know the slope formula. So you'll have those 2 points, and you'll do y minus y divided by x minus x and find your answer. Keep in mind that when you do that, that's the same thing as me drawing a line through these 2 points. And because I've drawn the line through both of those points, and it also hits the graph in those 2 places, that's called the secant line. Secant line crosses the graph in 2 locations. There will be a number C in between 2 and 6, the mean middle, such that, and I'm just estimating right up here in this purple point, such that the derivative, which is the instantaneous rate of change, but also means the slope of the tangent line. So I'm going to try to draw a tangent line through that point, but also touching that graph. This is the tangent line. So we'll call this is line T, this is line S. So basically the MVT has you compare the tangent line slope to the secant line slope, and if they are equal, notice how they're running the same direction, they're parallel. That's why it works. When you have parallel lines, you have the same slope. So when the tangent line slope is equal to the secant line slope, then the MVT theorem works. And so there's basically going to be some value here, and that value is going to be what they call the C in the book. Okay, so when you solve the equation that you set up after you set them equal, you solve for x, make sure that that value again is in between, somewhere in between a and b. So check your interval. So this is just a visual to kind of help you see what the MVT theorem actually does. Alright, so our first example is to find the values of C in the open interval from 1 to 4. Find the values of C in the open interval from 1 to 4. Alright, so we're going to do this in the same order. So we're going to do like step 1 is you have to find the average rate of change. Again, that's the algebra slope. Now, in order to do that, obviously, you're going to need, like I said before, you're going to need two ordered pairs. And the only thing you have right now is obviously the function, but you also have the open interval from 1 to 4. Meaning that the x values are 1 and 4. And so your job, before you can do the average rate of change, is to evaluate the function at these values to find the y. So we're looking for like f of 1 right now. And you'll put 1 in place of x. And you'll get 5 minus 4, which is just 1. And so 1, 1 is a point on the graph, on this graph. And then you'll try to evaluate f of 4. We're looking for the y value. Really easy. You're going to get 5 minus 4 divided by 4. And 4 divided by 4 is 1. So you're going to get 5 minus 1, and that answers 4. And this is a coincidence that actually the x and y values are the same, obviously. We know better from the past. So total coincidence here. So now, after you find, use your open interval and plug them in to figure out what the y values are, now you can actually do the algebra slope. And so the slope is going to be equal to 1 minus 4 on top, y values, divided by 1 minus 4 on the bottom, or you can go the opposite direction. And so the slope is going to be negative 3 on top, negative 3 divided by negative 3, or just 1. So my algebra slope is 1. Alright, finished with that. Excuse me. Now we're going to go to step 2. Okay, so step 2 is to find the calculus slope, or the instantaneous rate of change. So to do that, we're going to go back and pull that function down. I'm actually going to rewrite the function so it says f of x is equal to 5 minus 4 x to the negative first. Okay, when you do the derivative, the derivative of 5 is 0, of course. The derivative of negative 4x to the negative first, negative 1 times negative 4 is positive 4. Drop your x down and subtract 1 from the negative 1 to get negative 2. And then I'm going to choose to rewrite this so there's positive exponents, so 4 over x to the positive 2. So that is the derivative. Okay, so I found the algebra slope, and now I've found the derivative calculus. And so the next step in the process, we've done this one, is to set the average rate of change equal to the derivative. We're going to do that next, and then we're going to solve for x. And when you're doing your problem set, if it's an MVT problem, please go ahead and list your step 1, step 2, step 3 for me, just like I'm showing you. That's why I'm doing this on the board. So step 3, you're going to take the, I'm going to do the calculus slope first. So I'm going to write 4 divided by x to the second. I'm going to set that equal to the slope I found from step 1, and that was 1. And basically, you're just going to solve that problem. So I'm going to make this a fraction, and then I'm just going to use a cross multiply because it definitely is a proportion. So 4 times 1 is 4. 1 times x squared is x squared. And then you're going to take the square root. And so x value is going to be positive negative 2. And that's how you solve that equation. And so that's what step 3 looks like. Very straightforward. And then step 4, we've already done step 4. We've solved for x. We got 2 and negative 2. And now step 5, we're going to check the interval and then choose the c. And so the interval for this problem is here. It's 1 to 4. I look at my answers I just got, and I actually have a positive and a negative 2. So if the interval's from 1 to 4, I know that negative 2 is not obviously going to be in the mean or middle of that interval. And so I actually have to just say that c is a positive 2. And so that is how you would label step 4. And I'll just top it here. Again, when you're doing your own set, your own practice set, make sure that you do write down step 1, step 2, step 3, step 4. Please do that. Okay, and that is it. That's how you find values of c in the open interval. So when they give you the interval, but they don't tell you what the c's are. If they're using the mean value theorem, then this will always work. And I should have said this a second ago, but we do need to always consider, I said this in class today, that f has to be continuous, but it has to be continuous on this interval. And differentiable. So in this problem that I just went over with you, we can tell it's rational. We know it's a rational function, and we know from past experience that this 5 is actually a shift up 5, and the negative's going to make the graph or locate the graph in a different quadrant. So just very quickly, this is the parent graph of a rational function, but the one, let's try this again, but the one I gave you, this one is going to be shifted up 5 for the asymptote. to give you a visual here, this is going to be your asymptote. The negative is going to flip this down, so it's going to like go this direction and this direction, and then the 4 is going to make it a little bit steeper. So if you want to use your calculator, you can to verify, which is what I would do to make sure. Make sure you use parentheses around that 4 divided by x though. And so let me do this one in blue. So it's going to look like this, and it's going to look like this. Okay, so the blue graph is actually the graph of this function, and so we're just checking to see if it's continuous. Well, no, it's not continuous over the entire interval, but from 1 to 4, your focus is from, let's say, here to here. This piece is definitely continuous, and so that's why we're allowed to use the MVT, because we're not focused on the whole picture, just the part I highlighted in yellow. Okay, so that is MVT in a nutshell.